Sooner or later, you will discover the limitations of Kubernetes networking. That might be when you decide to do canary deployments. Or that might happen when the need arises to have secure communication between your services. Or you might need more complex or better load balancing for your services. You might desire more fine-grained metrics or tracing, or that could be rate limiting, access control, authentication, and so on and so forth. And when that happens, you will probably say, hey, I need service mesh. And one of the best solutions we have for service mesh, if not the best solution, is Linkerd. Today I'm going to do an introduction to Linkerd. We're not going to go through all the features it offers because that would be huge. That would be much longer than I have for this video. So think of this as an introduction, and then there will be follow-up videos with specific topics related with service mesh. So think of this as a starter kit. How do we start using Linkerd? And later on we are going to explore it in more depth. This is the beginning of a series of videos about Linkerd and service mesh in general. So let's start with service mesh, or to be more precise, why do we need a service mesh? To answer that question, think of your system as a number of different processes, separate processes spread across your cluster, across your system. And once we visualize those processes, we need to answer some questions, some very specific questions, like how do they communicate with each other? How do those processes talk to each other? And for them to talk to each other, they need to be able to discover each other. Think of that system as a hotel, and hotel has rooms, but the occupants of those rooms are changing. One room might be occupied by one family, another one by another, and then one family might move away and go somewhere else, and another one comes in. So the tenants of those rooms are changing all the time, and we need to wait to discover who is where and for how long, and where did somebody move. Did somebody upgrade the room and move somewhere else? Or maybe the vacation ended and then they left and somebody else came in, and so on and so forth. So hotel is very dynamic. Even though rooms are more or less static, people are moving in and out of those rooms. And if we want to talk with any of them, we need to figure out where they are, or at least what the number of their room is, so that we can call them or maybe visit them directly. If we extrapolate that to a system, to a cluster, that would be equivalent to service discovery. Processes are moving around, and we need to be able to find out where they are at any given moment. And the communication might be interrupted. Maybe we want to take an elevator, but the elevator stops working, and then we need an alternative plan. Should we take another elevator, or should we take the stairs if we want to visit somebody in a hotel? And the communication needs to be secure. It's not that everybody can talk to anybody. We need to give permission to somebody to talk to us when we're in a hotel. So the communication needs to be secure and restricted at the same time. You should be able to call any tenant in a hotel as long as that somebody allows you to call them. You cannot just contact the reception and say, hey, I know that Brad Pitt is staying in your hotel, please connect me to him. And the similar logic applies to the systems we're building, except the tenants are processes and the hotel is equivalent to a cluster, or maybe a group of clusters. So within a system, processes need to be able to communicate with each other. They need to be able to find each other. We need to figure out what happens if communication gets interrupted. We need to be able to trace that communication. It needs to be secure, and we might need to restrict communication in certain circumstances. To accomplish all those things, especially in complex systems, we need to be able to perform certain number of tasks. We need discovery, we need load balancing, failure recovery, collection and querying of metrics, monitoring, progressive delivery like A/B testing, blue-green deployments or canary deployments, rate limiting, access control, and authentication. You might not need all of those things. Almost nobody does. But I bet that you need some of those, if not the majority. And that's where service mesh comes in. Service mesh is used to describe communication between components in a system. In a simplistic, very simplistic view, service mesh manages networking between processes, between components in a system. And the tasks or the features of a service mesh can be split into three major groups. We have observability, like telemetry and tracing and monitoring. Then we have security, especially MTLS or mutual TLS, which is in charge of securing communication between all the components. And finally, there is reliability, which can be retries, timeouts, load balancing, traffic splitting, fault injection, and so on and so forth. Now, I will not go into more detail about service mesh in general. If you're interested in service mesh, I can recommend this video. The link is in the description, so go and check it out. For now, we are going to focus on one implementation of service mesh, a good one, and that one is called Linkerd. As you can see from the description I gave so far, service mesh is a massive topic and it cannot be explored in 20 minutes or half an hour or something like that. So today we are going to focus on basics, how we can set up Linkerd, what we can do with it, and a few other things. And later on in upcoming videos, we're going to dive deeper into each of the points that I mentioned so far. So let's get going, let's install Linkerd and see what we can do with it. Let's start with installation and setup of Linkerd. You will need two things as prerequisites. To begin with, you need a Kubernetes cluster. Hey, everything needs a Kubernetes cluster today. And you will need an ingress controller. Unlike some of the other service meshes like Istio, for example, Linkerd does not come with the ingress baked in. And that's both good and a bad side. On one hand, it would be nice if ingress is baked in, but on the other hand, this gives you freedom to choose any ingress you want. So create a Kubernetes cluster and install any ingress you like. Just use ingress that you normally use in your Kubernetes cluster. In this demo, I will be using Rancher Desktop, and if you're not familiar with Rancher Desktop, it's amazing. Check out the video, the link is below in the description. And Rancher Desktop is based on K3s and it comes with Traffic ingress, so it already comes with ingress out of the box. Next, I will execute a script that will install Linkerd CLI on my laptop, on my computer. So just execute the script and you will see in the output instructions how to add the binary to the path if you do not know already how to do that, and you probably already do. You should actually add that export command to your bash rc or zshrc or whichever shell you're using, and that way you will not need to export the path every time you want to use the CLI. And now we can finally install Linkerd in a Kubernetes cluster, but before we do that, Linkerd CLI provides a very nice and nifty way to double check whether your cluster has everything it needs to have for Linkerd to run. So I'm going to execute Linkerd check --pre, meaning pre-installation, before the installation starts. And in my case, that showed that there are no problems, there are no issues. I should be able to run Linkerd in my cluster. So let me get to the manifest first, and I can do that by executing Linkerd install. If I would be using this for real and not for a demo, I would store those manifests in a Git repository and probably use something like Argo CD or Flux or any other tool that you use to synchronize what's in Git and what is in your Kubernetes cluster. But since this is a demo, I will execute that command again and pipe it directly to kubectl to install it directly. So I will skip all GitOps, Git repositories, what's or not type of process and go straight into installing it in my cluster. Linkerd is installed, but we are not yet finished. There are a couple of other things we need to do. We are going to execute another check. This time it will be post-installation check to validate that everything works as expected. This takes a couple of moments, so let's wait for a second, wait a bit more, and there we go. It's installed, it's ready. But we do not have all the components there yet. Apart from running Linkerd itself, we should have means to monitor the traffic, and we are going to do that through a combination of Prometheus and Grafana. And we also need to be able to trace requests and see how they're flowing through our system and what is going on with those requests, and we are going to do that with Jagger. To simplify things, Linkerd already comes with packaged Prometheus and Grafana. If I already had Prometheus and Grafana up and running, I could use those, but it's nice to use the packaged version, the one that is baked into Linkerd, because it comes already with predefined parameters, values, and dashboards and everything else we might need. So I will execute Linkerd viz install. Viz is the name of the package with Prometheus and Grafana, and then I'm going to pipe it to kubectl so that it is installed and running in my cluster. And I will do the same thing with Jagger by executing Linkerd Jagger install and then pipe it one more time to kubectl apply. And that's about it, at least when setup is concerned. Actually, let me double check whether everything is okay by executing one last time Linkerd check. and waiting and waiting and waiting, and yes, everything seems to be correct, everything seems to be running. So let's go into the real deal. Let's see how we can instruct Linkerd to attach itself to our applications, to our services. We need to tell Linkerd which of our applications we want to meshify, which ones should be using service mesh, because not necessarily everything in a cluster should be under the control of a service mesh. Linkerd attaches itself to pods of our applications by adding additional container that acts as a proxy. That's a container that monitors and controls and do whatever needs to be done with traffic coming into our applications or out of our applications. And we can do that by adding an annotation. And to make your life simple and this example fast, I already added an annotation to a sample application we are going to use today. So let's see how that looks like. Here I have a set of manifests defined in customize format. If you're not familiar with customize, do not worry. First of all, it doesn't matter whether you're using customize or Helm or pure Kubernetes YAML. Linkerd works with any of those. And the second thing I should tell you is that there is a link to customize video which you should check out if you're not using it already, because you might want to use it. It might not be a bad idea, and I even have a video that compares customize with Helm if you're interested in knowing what are the pros and cons of using either of the two. Anyways, let's take a look at the deployment manifest of this application. And this is a typical deployment. There is nothing special here, so I will not go and explain how deployments work. That's basics. You probably already know that. What matters for now is that there is an annotation saying Linkerd io/inject, and then the value is enabled. And then I have the ingress resource, which also needs an annotation and which depends on the ingress controller that we are using. For traffic, I had to add an annotation that says ingress Kubernetes io/custom request headers, and then the value is 15D DST override. Just follow the instructions and you'll figure out what you need to do. And in my case, I'm saying, hey, you should overwrite and redirect things to DevOps toolkit.production.svc.cluster.local, which is the fully qualified address of the service of this application, and the port is 80. This might seem intimidating at the first look, but it's really not. You just need to add one or two annotations depending on the ingress resource you're using. And now I can deploy the application. I can do kubectl apply. And remember what I said before, in a real world situation, I would not do kubectl apply. I would use Argo CD or Flux. And if you're not familiar with those, the links are in the description. But for simplicity, right now I'm doing kubectl apply and then customize and the path to my manifests. Now let me take a look at the pods of this application, or to be more specific, I want to see how many containers each of those pods have. And we can see that there are 2 containers in each pod, even though if you go back to the manifest, you will see that I defined only 1 container. The second of the 2 containers is the one that was injected automatically by Linkerd. That's the container that acts as a proxy and monitors, controls, and does whatever needs to be done with the traffic coming into this application, into this service, and going out of that application or that service. To be on a safe side, I will double check whether my application is really working, whether it's really operational, by outputting the address and then opening that address in a browser. And as expected, the application is up and running, so everything is good. And we haven't done much yet. We only instructed the Linkerd that the application exists and that it should attach a proxy to that application. And we are yet to see what Linkerd can do from now on. Now let's do something useful. But before we do, let me stress out one more time that this is not complete Linkerd tutorial. I will do that in the follow-up videos. I will show you how to do canary deployments, for example, or how to do MTLS, how to do this and that. We will go in much more detail about Linkerd in upcoming videos. For now, I want to focus on basics. I want to focus on observability, how we can get insight in what is happening with our applications from the networking perspective. And before I show you anything, I need to generate a bit of traffic, and I will use the DDoSify tool for that. It's a simple CLI tool that is absolutely awesome, or potentially awesome. And if you do not have it already, the link is in the gist. And that just reminded me that I did not tell you that there is a gist with all the commands. If you want to reproduce what I'm doing, please follow the instructions in the gist, and the link to the gist is in the description of this video. I should have said that at the very beginning, and I'm telling you now, there is a gist with all the instructions how you can do everything I'm doing right now. But going back to the main subject, I will run DDoSify to generate some traffic. I will generate 100 requests going to the root of this application. Later on, we might do some more complex scenario, but for now, 100 requests should be enough to see some results, to see some movements in our system. There are two ways how we can visualize network traffic going in and out of our applications. We can do it through CLI, through a terminal, or we can use a web UI. I'm going to start with the terminal first because there are a couple of commands that might be useful. And the first one I'm going to show you is Linkerd with stat, which gives us statistics for any Kubernetes resource, at least any Kubernetes resource that is meshed. Anything that has Linkerd proxy, the one that we instructed Linkerd to put through the annotations. So I can execute something like Linkerd and then -- namespace, it's production in my case, and then viz, short for visualize, stat, and the resource we want to get statistics from, which in this case is deployment called DevOps Toolkit. And I can see basic information here, arguably the information that you need the most, at least at the beginning, and that information is, hey, this is the name, this is the number of meshed pods. If they're not meshed, if they do not have a proxy, you don't get statistics, and then 100% of requests were successful. This is response per second. These are different latency buckets. And finally, this is the number of TCP connections that we have right now. We can also get viz top statistics, which are real-time statistics of the pods of an application. And in this case, I have 3 pods, and we can see all the methods that are executing. They're all get right now. We can see the paths and the number of requests, the count, which is 2, because I'm not sending any traffic right now, so those 2 come from Prometheus. And we have best and worst and last response time, and finally the success rate. There are quite a few other commands that you can execute to get different types of information, sometimes live and real time, sometimes past information, but I'm going to skip through all that, and we're going to jump straight into pretty colors. I'm going to show you the web UI that shows us information in different format, in format that is arguably easier to digest, even though the information is the same as the one that we can get through the CLI. And we can open the dashboard by executing Linkerd with dashboard, and then it opens in its full glory in a browser. In the main part of the home page, we can see HTTP and TCP traffic, and you will see all the services that are currently running in this cluster. There's not much because this is a demo, but nevertheless, all the services. And what matters, what is really important, is that you will see that there is no information for the services that are not meshed. So metrics are collected only from those that have the Linkerd proxy attached. And as you saw before, we can attach the proxy by adding an annotation. So we do not get metrics from everything in a cluster, but only those that contain Linkerd proxy. And that's Linkerd itself and all the applications that have the specific annotation, the one from the very beginning. And in my case, the demo application is in the production namespace. So I'm going to switch the namespace to production and take a look at what we have over there. And we can see the deployments and the pods and the replica set. And we're going to go through those in a second. For now, I want to start generating additional traffic so that we can see what's going on. So I will execute DDoSify again. I'm going to use a config file so that the traffic goes into different routes and it lasts for a while longer and sends more requests to the application so that we get a better feeling of what's going on. Okay, so now that I'm generating some traffic, let me go into the deployment itself of that application, and we can see that there are 2 sources of traffic, Prometheus and TAP. That's internal traffic that is generating metrics, and anytime now we should get a 3rd source. And now we got a 3rd source that says unmeshed, and that's because I did not add the annotations that would mesh traffic itself, and the requests are coming from traffic, which is ingress. That really doesn't matter for now. What matters is that it detected that there is some traffic coming from the ingress, and it included it in the list of the sources of the traffic to that specific application. If we go down to the live calls section, we can see traffic split depending on the path where it goes. Some traffic is going to root, some traffic is going to /post/YouTube, and the rest of the traffic is going to /post/catalog. Those are different pages in this silly application. What matters is that we can see how many requests are happening right now. That's the count. We can see the best and the worst and the last response time, and we can see the success rate being 100% at least right now. Now I will leave you exploring the dashboard by yourself. What I will say for now is that you should pay attention to different icons on the right side, like there is icon of Grafana. Feel free to click it and you will see a dashboard with data filtered for that specific resource in Grafana, with much more information, with more colors and graph and pie charts and table and all the things that make us love seeing things on our screens. I will not go into Grafana in this video, you should check it out yourself. That's also coming. We're going to explore Linkerd in much more depth in upcoming videos. For now, I just want to give you a quick introduction and a taste of what it might be able to do. Actually, you didn't taste it yet. You haven't seen things like canary deployments and fault injection and retries and timeout and HA and multi-cluster communication. There's a lot to see and do with Linkerd, and we're going to explore it all, but not right now. This is the end of this video. Much more about Linkerd is coming very, very soon. Or maybe it's already there. It all depends on when you're watching this video. Thank you so much for watching. See you next time. Cheers.